Look up tonight, the moon is there. Cold, pale, enormous, hanging above the horizon like it has always been. It has not always been there. Not exactly there. The moon is drifting away from Earth at 3.8 centimeters per year, that is the measured, confirmed laser-verified answer, not an estimate. Not a theory, a measurement precise to the millimeter. On July 21, 1969, Apollo 11 astronauts placed a flat panel of glass prisms on the lunar surface at Tranquility Base. It is still there today. Since 1969, observatories on Earth have been firing laser beams at that panel and timing the reflection. The beam travels 384,000 kilometers, bounces off the prism array, and returns by measuring how long that round trip takes. Scientists at the Jet Propulsion Laboratory, led by James Williams, confirmed the moon retreats 3.8 centimeters every single year. In 1994, that number was published in the journal Science. Definitive and precise. 3.8 centimeters, about the width of 2 fingers. But here is where it gets strange. That tiny annual drift carries an enormous consequence hiding inside it. The same mechanism pushing the moon outward is also slowing Earth's rotation. Your day is getting longer. Not fast, 2 milliseconds per century, according to researchers F.R. Stephenson and L.V. Morrison. But over deep time, that adds up to something staggering. 400 million years ago, Earth's day was only 21.9 hours long. Scientists confirmed this by reading growth rings inside ancient Devonian coral fossils. The ocean is doing this. Earth's own oceans. Which raises the question that the next few minutes will answer. How does an ocean push a moon? The mechanism is stranger than you expect. Here is what is actually happening. Right now as you read this. The ocean is not sitting still. It never does. The moon's gravity reaches across 384,000 kilometers of empty space and grabs Earth's water, pulling it into a gentle, planet-wide hump, 2 humps actually. One facing the moon, one on the opposite side. The entire mass of the world's oceans, slightly deformed constantly. But here is where it gets strange. Earth spins faster than the moon orbits. One full spin takes 24 hours. One full orbit takes 27 days. Because of that mismatch, Earth carries those 2 ocean bulges slightly forward, ahead of the moon's position, like a dog pulling hard on its leash. The bulges are always running a few degrees ahead. And those bulges have gravity. That forward bulge pulls on the moon from slightly ahead. It is a gentle, constant tug. Not dramatic, not violent, but it is real. And it never stops. It acts like a gravitational hand pressing the moon forward into its orbit, nudging it outward, millimeter by millimeter, year after year. The more massive the ocean bulge, the stronger the pull, the faster Earth spins. The further ahead the bulge sits, the further ahead it sits, the harder it pushes. Earth's own rotation is the engine driving the moon away. George Darwin at Cambridge calculated this mechanism in 1879. He was right, the physics is clean. Almost elegant, a spinning planet. A gravitational bulge, a moon getting a perpetual slow push. The ocean is a machine. It has been running for 4 billion years. But every machine has a cost. If the oceans are spending energy pushing the moon outward, where does that energy come from? Something must be slowing down to pay for it. That something is Earth rotation itself. And what that means for the length of your day is the reason this chapter exists. Sources, Darwin, G.H. 1879, Proceedings of the Royal Society, Dickey J.O. et al. 1994, Science, 265, 5171, 482, 490. Jeffries H. 1920, Philosophical Magazine, NASA Jet Propulsion Laboratory Lunar Laser Ranging Program. Here is the proof, not theory. Proof you can hold in your hand. In 1963, a paleontologist named John Wells did something no one had thought to try. He counted the growth rings on a 400-million-year-old coral fossil, the way you would count rings in a tree. Each ring was 1 day. And when Wells counted an entire year's worth of rings, he did not find 365. He found 400. 400 days in a year. Same year, shorter days. That single fossil was telling him that Earth, 400 million years ago, was spinning faster. A day back then lasted only 22 hours. The planet has been slowing down ever since, one stolen fraction of a second at a time. But here is where it gets strange. Those seconds are not disappearing. They are being transferred. The same tidal friction that pulls the moon outward is also acting like a brake pad on Earth's rotation. As Earth slows, the moon climbs higher. It is one transaction, two effects. Angular momentum, the physics term for spinning energy, moving from one body to the other like water flowing between two tanks. Geologist George Williams confirmed this in 1997, studying ancient tidal rock layers called rhythmites in South Australia. The sediment was laid down 620 million years ago, each layer recording tides, each cluster recording a month. His count 400 days per year, with days lasting 9 hours. The measurement did not come from a calculation. It came from stone. Scientists at the Apache Point Observatory in New Mexico have since confirmed the modern rate precisely. They fire laser pulses at reflectors left on the moon by Apollo astronauts. The returning light tells them, to millimeter precision, that Earth's day is lengthening by 2 milliseconds every century. 2 milliseconds per century, it sounds trivial. Compounded across billions of years. And the question becomes unavoidable. If this has never stopped, where does it end? Here's the part no one tells you. The moon was not always a distant, cold disk hanging politely at 384,000 kilometers when it first formed. 5 billion years ago, it was only about 24,000 kilometers away. That is 15 times closer than it sits tonight. Something caused that, something violent. Scientists call it the Theia impact. A planet the size of Mars struck the young Earth at an oblique angle. This planet had its own iron core, its own geology. The collision was so catastrophic that both bodies partially vaporized. Debris sprayed outward in a ring. Within decades, by cosmic standards, almost instantly, that debris collapsed into the moon. But here is where the scale becomes genuinely hard to hold in your mind. The moon that emerged from that debris was close enough that the tides it pulled across early Earth were not meters high. They were hundreds of meters tall. Walls of ocean surging across bare rock, driven by a moon so enormous in the sky it would have been unrecognizable. And those brutal tides did something critical. They stabilized Earth's axial tilt, the 23.5-degree lean that gives every latitude its seasons. Without the moon's gravitational steadying hand, Earth's tilt could wander chaotically, according to research published in the journal Nature in 1993. Stable seasons, stable climate, the slow, patient conditions that complex life requires. The moon did not just form near us. It made us possible. Now follow the trajectory forward. 50 billion years from now, the recession stops. Earth's rotation will have slowed until one day lasts 47 current days. The same face of Earth will permanently point at the moon, mirroring what the moon already does to us. Two worlds locked, frozen, staring at each other across a silence the tides once filled. The moon is leaving. It built the world that would eventually notice it was gone. Sources: Canup RM and Asfog. E. Nature 2001. Laskar J. et al. Nature 1993. Dickey J.O. et al. Science 1994, Tauma J. and Wisdom J. Science 1994. Go back to that hillside. The same cold air, the same pale light. The same moon hanging above the horizon, enormous and unhurried. You know something now that you did not know when you first looked up. That moon is 3.8 centimeters farther away than it was this time last year. Not a crisis, not even visible, but measurable down to the millimeter, by a laser beam fired from a telescope in New Mexico, bouncing off a small aluminum panel sitting silent on the lunar surface since July 1969, and returning home too, 5 seconds later. Think about what that means. Humans built a tape measure 400 kilometers long, and with it, we are watching something leave. The leaving is ancient. It was running before the first fish, before the first cell, before the first ocean wave broke on bare rock. It will keep running long after every name we have ever spoken is forgot. But here is what stays with you. The moon was not a passive backdrop to life on Earth. It steadied the planet, it slowed the spin. It pulled the tides that may have rocked the first chemistry of life back and forth in warm, shallow pools. The world that made you required it. Ancient coral recorded this in stone. A fossil holds the count of days in a year that no human ever lived through. Science is sometimes just learning to read what was already written. The laser fires, the beam travels. The signal returns. James Williams at JPL ran those numbers for years. And what they spell out is not loss but a transaction, patient and enormous, that has been settling its accounts for 5 billion years. Tonight, look up. The moon you see is the same one. It is also by 3.8 centimeters already gone. Subscribe, a new breakdown like this every day.